Isomorphisms. We looked at isomorphism briefly in linear algebra. Remember, there was the picture in the book between your cell phone and the laptop computer. So they both do many of the same things. So what we're going to be looking at are two graphs, a G and a G prime, and we're going to be finding that there's a relationship, and you'll notice I've listed all of the vertice names, so the V's from the G, the W's from the G prime, and I'm going to show that there's a relationship between the V's and the W's, and move on to finding the relationship between the edges in G and the edges in G prime. Okay, so let's do it. So I'm looking at vertex 1. Vertex 1 has degree 1, 2, 3, 4. So I'm looking for a vertex of degree 4 in this graph in G prime. I'm thinking it's W2. Then I'm looking at vertex 2. So vertex 2 is in here. It has a degree of 2, and it's connected to the vertex that has degree 4. So vertex 2 looks like it would go to W3, right? It's connected there, has for degree 2. So vertex 2 goes to W3. And then V3, which is over here, it has degree 3 and is connected to the vertex with degree 4. So that looks like W1, degree 3 connected to the one of the degree 4. And so then V4 and V5 are what's left. So V4 and V5. So V4 looks like it would go to this other degree of 3, right? So V4 goes to V5 and V5 goes to V4. Okay, so then I come over and do the same with the edges. So I match the edges. So edge 1 over here is, where is edge 1? Did I forget to label edge 1? I think edge 1 is up here. I don't see edge 1. Must be this one up here. Okay, edge 1 is up here. Edge 1 is up here, and it's connected to a degree 4 vertex and a degree 3 vertex. So I'm looking for a degree 4 and a degree 3. I think F3 would work. I think F7 could work also. So it's not unique, but I can see that there's a relationship between these two. So then if I move on to edge 2, which is here, so edge 2 is between two vertices of degree 3. So I'm thinking that that would be either F1 or F2. So I'm just going to go with F1. And then E3 is going to go to F2. Now moving over to E4. So that's a connecting between a degree 3 and a degree 4 vertex. So that looks like it would be this F7. And then E5 here, connected this edge here between the degree 4 and just a degree 2, degree 4 and a degree 2. So that would be either F4 or which one am I doing? E5. Lost a second here. E5 is this one, degree 2 to degree 4. So E5, degree 2 to degree 4. Oh, here, right here, F6. F6. Then E6 would be the other way, right? Between the two degree 2 guys. So that would be your F5. And then last one here. Okay, so that's when you can find an isomorphism. You can find a relationship. Okay, so when they're not isomorphic, one of these things is not going to happen. So they're called invariant. And so if you're asked to find an isomorphism between two graphs, like this G and this G prime, and I didn't even label them, but look to see if you can find an invariant. Which one of these things makes them not possibly have an isomorphism? So this one here, I notice, has 7 edges, right? This one here has 8 edges. So that's called the invariant. So since the number of edges are not equal, you can't have an isomorphism between them. Okay, so looking at these, I see this vertex right here has degree 4. Is there any vertex here that degree 4? None. So there's no vertices of degree 4 here. So that's why it's an invariant that you cannot find an isomorphism between them. Okay, so I just give you some more for practice. So let's do it. So here's V1, V2, V3, V4, and then W1. And so when they give you all of the edges and vertices labeled, then it's your job, your job to find the relationship between the edges and the vertices. So this one, I have to do both. So let's see. So V1 is here, has a degree 1. Well, there's only one, right? It's W4. And then V2 is here, has degree 2. So that's got to be the W3. And then V3 is here, and it's got degree 3. So that's got to be this W2. And then the last one, V4 to W1. Okay, so I found a relationship between the vertices, and so then it's my job to find the relationship between the edges, E4, and then F1, F2, F3, and F4. Okay, so All right, so E1 is here. So it's between the degree 1 and the degree 2. So for sure that's F4. That's pretty straightforward. E2 is here between a degree 2 and a degree 3. So that's got to be this one, right? So that's F3. And then, oh, wait a second. Which one did I just do? I think I made a mistake. Hold on a second. So I was looking for E2. Oh, silly me. Okay. I was looking for E2. E2 is between, so that's F3. E2 is F3. Okay, then E3 is between, is going to be either the F1 or the F2, right? So I'm just going to give it to the F1, and then this one would go here. Okay, so is there an isomorphism? And if not, find the invariant. So if I start looking, can you see this graph has 5 vertices, right? V1 up to V5. And then this graph has 6 vertices. So since we've got a different number of vertices, there cannot be an isomorphism.